So it is time, so let's just get going.
Okay.
So, well, good morning, everyone. Good morning, everyone. It's once again a very nice presentation we're going to have today. We're going to start with Professor André Chagas from the University of Sao Paulo, Brazil. And as you can see from his slide, he's going to speak about questions related to neighborhood effects in Brazil. And then we're going to move from Sao Paulo to Chile, where Alicia Chávez, who's a PhD student over there, is going to speak a little bit more about public spending and economies of scale in Chile. So André, whenever you're ready, it's all yours. Thank you so much to both of you.
Thank you, Sandy. Thank you for whole. It's a pleasure to come back to Rio in virtual mode, but I am come back to Rio, and I will present a work with my student Denise Lee. It's part of the PhD thesis of Denise, and you are investigating the neighborhood effect consumption. You are looking to the how kind of a spillover or interaction effect are in the consumption, looking to the budget of the family in the household, the effect of the neighbor of this family in the decision of consumption. Then I will present. I have a small time, I suppose, to present, but I will think to follow the rule and follow. I think that you have in this work two main contributions. One of this, one of them is methodological, because we are in some spatial effect in the regular demand system estimation, and I will comment how the improve in this model you need to do to estimate this this spatial effect. And, the second one is the estimation. We are using a spatial SUR model, but to estimate a demand system, we need to apply some restrictions, and you need to change the method and the package existed. We need to adapt the code to impose restriction in the estimation process. In general, what what is estimated in the consumption is how the family and the household decide the budget in different goods, and the problem that we see what people choose, but we don't see what the people don't choose. This is a classical problem in the consumption estimation. Deaton, the price Deaton has a good contribution to this literature, introducing an approach that could investigate not in the ideal way, but in the almost ideal way, how to investigate the consumption and the decision of consumption of the family. But as usual in the traditional, in the classical model, the model do not consider the spatial effect. Then we are introducing this spatial effect because we think that this is more realistic demand models, and you need to provide some insights about public policy, about the taxation of the family or consumption taxation, for instance. what is the mechanism that is playing the spatial interaction or the peers interact between family? One of them is keeping up with the Joneses, is follow the majority of your neighbors and to choose not only maximizing your direct utility function, but adapt the utility function to mirror some kind of conspicuous could because they are visible. I can see what my neighbor chose. Then I can my decision to choose a similar one, or if the correlation is positive, or to choose that one if the correlation is negative. Other kinds of mechanisms could include risking. I prefer to follow a group than decide alone, or some identify quality or signal of quality in some products that I don't know, but I saw my neighbor choosing kind of goods. Then I think that this is some kind of thing that is planned. What the consumption could be spatial correlated. The problem in this estimation is I only follow the literature, mainly Mansky, that identify three endogeneity problems, and the spatial literature treat this endogeneity. For instance, the first using the spatial autocorrelated model, and the second as a SLX model, a spatial lag in the dependent variables model, and the third one using the spatial error model. And I suppose that the most of the group knows about these models. Then I will avoid to comment detail there. We are not alone in this kind of investigation. Some papers in the literature try to identify similar problem as we. Like the first example in India, or another in Mexico, or maybe in Denmark, and the last one, I think that is more similar as problem and our data. They use scanner data. They scanner tickets in a zip code area, and could see how the neighborhood in this area consume different kinds of goods. And then they try to how the neighborhood effect occur in this area. Okay, our first contribution, as I said, is to adapt the classical demand system model. The name is the almost ideal demand system. This is due to the detail in the first one, but follow a standard territory using this model and adapting this model in different contexts. In general, they use a log linear model to model the utility function. And the utility function is the sum of two parts. The first one is the subsistence consumed and not subsistence consumed in the part B. And they specify the A and B part of the model using a relation between price of the goods and the price of the whole other goods in that way, and in the B part in that way. They show that using the regular Shepard lamb, they derive the demand system, the Marshallian demand function, looking not only for good, but for share of good, the share of budget spent in this good in this way. Okay, I will avoid some details of this equation. And this is the traditional restriction to make the system consistent with the consumer theory. Then we put in the part A of the utility function a spatial relationship, how share of the consumption of my neighborhoods, impact the decision of the household to choose share of consumption of any good. And if you put this additional part in the part A of the utility, and again using Shepard lemma, we can show that the new share of consumption function become this. And the difference of this from the traditional is the spatial autocorrelated part, like here. Okay, and we have an additional coefficient, not only looking to price or income, but also to the of the neighborhood in this equation. And lambda represents the impact of change in a share consumption of the neighbors in the share of consumption of the household. As we have this additional parameter, we need an additional restriction also. This is not discussed in the previous literature, how to conform the spatial model with the consumer theory. And then we show that this additional restriction is needed to do that. In the estimation part, then a spatial SUR model, because you have a system of equation, one equation for it good. And in each equation, we have observation about the household. This is a SUR, assembly and related regression estimation. And we adapt the existent spatial SUR model to input or to put our restriction, as I commented before. And as traditional in the models, Now we have richer marginal effects, not only the marginal effects of the family in itself, but the family in the neighbors and in the neighbors to the family again. This in the spatial literature is named direct effects, indirect effect, direct effects, look to the whole feedback effects of in itself, and the indirect effects looked to the average effect of the family in the, and the total effect is just the sum of this these two effects. Then we have now when the price change, it's not only average change in the price, but is the price changed by in a specific family, and the family we change the consumption because of this change in the price, but changing in its its consumption, they will impact the neighborhood consumption and so on. Okay, I need to you use identified database provided by the Institute of Economic Research Foundation, FIP, in Brazilian, in Portuguese, a crown. This institute is linked to the Department of Economics of my university. Then you have access to the microdata about household, each household consumption. We have more than 3,000 households that were interviewed in the period of 2009 2013. And then this is how the family is sprawled to the São Paulo. This is the São Paulo city. This is the center of the São Paulo city, and you have a lot of families cover almost the whole of the city of São Paulo. And then in this paper, we investigate some kind of concern because we have a computational problem here because it additional good that you put the system increase a lot. Then you have to limit the number of goods, category of goods. Then we investigate in this time the decision of consumption in different general category like habitation, food, transportation, health, clothes, education. This is the general, and this is a whole category that used total budget of the family in this kind of category. And on exercise, we take the food category and consider a subcategory of foods like pork, meat, fish, vegetables, fruits, flour, and dairy and sweets. Then this is the subcategory of food. Then you have two systems of equation, this first one and this second one. The results to the present, the results, when I put in the spatial SUR model, we have evidence that the spatial correlation coefficient is significant for virtually whole models, mainly when the second panel of our data, 2011 to 2013, in whole, I mean the broad category or in the food category, spatial coefficient is significant highly significant in some case. What is the estimation if I use only the traditional effect and not the effect? In general, the feedback effects, looking to the direct and indirect effects, compared to the classical results, the no spatial results, the difference in the coefficient in the marginal effect between 0.6 to 2.6%. And this could be important, for instance, in a taxation decision. And then the indirect effect in the neighbors represent in the smallest case just 1%, but in some case indirect effect could represent about 1/4 of the direct effect. For this, when I compare the difference in the elasticity estimated by the model, we can see in some cases that the difference is significant. Some goods that we could be considered in this case elastic good could not be so elastic as the traditional suggest. In another cases, for instance, when we look to the old category, the income elasticity estimated by the spatial model is very different than the traditional one. In some cases, clothing, for instance, the traditional model will estimate it as a luxury. Good.
Professor Chagas.
Go ahead, Andre. I think it's somebody who was not muted. Go ahead, please.
Okay, perfect.
I'm trying to ask a question. I have a question, Professor Chagas.
No, question will be at the end. Questions at the end, please. We respect the way we do the seminar. Thank you. Go ahead, Andre.
Okay, I am finishing. This is the main contribution in the empirical part. I think that in some cases the spatial and the neighborhood effect could improve the elasticity estimation, because we are looking to the final result here and not only the instantaneous result as the traditional model could have. Okay, then this is a progress, and you have a lot of work to do, of course, and you needed to improve the disaggregation to improve the elasticity, mainly in this moment in Brazil when we are discussing to change the consumption. To have better elasticity to estimate the impact of this change could be important, and you could improve the SUR model in using a panel data model, because families in this period the FIP investigates some families more than one time. Then you can, for this subgroup or subsample, we can consider some fixed effect, family fixed effect, for instance. I think that it is this. I am available to the question. I think that you have one guy.
Okay, but let me start. Let's follow the way we usually do things. And sorry for being disturbed during your presentation, Andre, on that. So thank you so much. Very nice work. I have actually 2 points which are more clarification points for you, Andre. The number one, I did not fully get what kind of weight matrix you're using. Is it just neighborhood, or is it somewhat including the social network of the people? I don't know if you mentioned it. Unfortunately, my internet was down and I was cut for a few minutes. So you may have covered that. And my point number two is whether or not you control some for family characteristics. Obviously, the share of what is being spent of your for your consumption varies pretty much based on the size of your family and also on the income of your family. So are you controlling for those two factors?
Yeah. Thank you for the opportunity to complete my presentation. We are using a geographical matrix, and we select a k nearest using the archaic criteria information, and then you test different k of k neighbors, and you choose that one that had the smallest IC this is the first point. The second point, yes, of course, I don't comment in my regression, but I use a lot of control of family. Let me show you. If I can share again here. And you have some demographic or characteristics of family, like income, like the general of the head, level of the education, the number of child, and the size of the family. This variable are controlled in our regression.
Fantastic. If I may, Andre, come back really quickly on that W matrix. How do you actually build it in a case where households actually live in apartment buildings, you know, from one floor to another floor? Obviously, the distance between them is 0. How do you account for that?
Mm-hmm. Yeah, in our case, we don't have this problem, fortunately, because it's not a very good sample. It's very big sample. It's just 3,000 families in whole city. Then FIP prefer to sprawl the families between the city. And then we don't have this kind of problem, but I think that this is an interesting problem, of course. But as I don't use a distance.
Yes, you're right. It's a k nearest. You're right.
Yes.
Okay. Yeah, that's true.
With k is just counts.
That is true. That is true. Okay. Why don't we collect additional comments and questions, please?
Yeah, Professor Chagas, I would like to go next. This is Noé, and first, a very impressive extension of Deaton's almost ideal demand system. Hopefully, you are able to come with something similar for the quadratic extension. But my question was mostly theoretical, the theoretical implications of having this this kind of peer effects, because I noticed that you mentioned Veblen in the beginning and the concept of conspicuous consumption. And as I was noticing the composition of the income elasticities, I wonder if in the derivation of the income elasticities, there is some part in which it appears those peer effects, and you can actually define them as some Veblen effect or some conspicuous effect, for example, when income increases, such as to define it as how much I want to show off as when my income increases.
Yes, we, to compute the elasticity, the traditional elasticities are computed using this formula. Of course, if you have a different specification of utility function, we will change this result of elasticity. Now we decided to start as the simple utility function as possible, because we are replicating you inputting a spatial model, but okay, is part of the agenda, including specification. The main point is that beta is impacting beta and delta is whole parameters impacting the elasticity.
Right.
Now in our we have three kinds of elasticity. We have the elasticity derivative of the direct effect, the indirect effect, the total effect, and we will compute the three elasticity. Now I simplify my presentation, of course, but in the thesis we show how to adapt this to consider the estimation of the marginal effects, because beta is not more beta, but is beta of the direct, indirect, and you have here the global spatial effects, the 1 minus rho W matrix is -1, okay?
Okay.
Noe, I think we're going to move on to the last question. You can always follow up by email with Andrea. I think somebody had a question, the presentation.
Yeah, Andre, this is Jeff Ewings. Greetings, and nice to see you again. In some of the work we've done in Chicago in the US, I think the point Sandy made was that family size and family characteristics, for example, the number of people who are working as opposed to just the pure size of the family is important. But secondly, we found that there are enormous differences in terms of consumption by income class and by age. And I'm wondering whether you might want to adopt a regression analysis where you take those characteristics into account, following some of the work of Dan McMillan, so perhaps using a quantile approach, and I wonder whether you'd consider that. But thanks for a nice presentation.
Thank you, Professor Jeff. It's a pleasure to answer your question and observation, of course. We have a lot of work is in this kind of literature. I think that we are only putting a small contribution because and limited by our data. Our data don't ask in our sample. We have question asking for people about the firm that work or the club that frequent or church that they follow, and I think that this are other dimensions to putting spatial analysis. And I think that our results call attention that it's important to consider this kind of relationship in the elasticity estimation, mainly if we are interested in the policy, we are interested in to estimate how the of one policy like taxation. I consider, of course, that the proximity is the lower kind of the spatial relationship, but mainly in this case, our results suggest that it is important.
Okay, thank you so much, Andre. Very nice presentation, very exciting work. I think we're going to leave it to that, and then we are going to move on to presentation number 2 by Alicia Chávez. So Alicia is currently a PhD student at the Catholic University of the North in Chile. And today she's going to speak about public spending, economies of scale in partial fiscal governments, and she has applied her work to Chile. So Alicia, muchísimas gracias for being with us today, and it's all yours. I can see your slide, so you're ready to go.
Okay, thank you very much for the presentation, and thank you for the opportunity to present in this seminar. Well, just as Sandy said, this is part of my PhD project here at Universidad Católica del Norte in Chile. This is currently a work that is still in progress. So you will see that I will present very, very preliminary results. And also, therefore, I think that this is a space that will give you the opportunity to receive your comments and suggestions. The title of the project is Public Spending and Economies of Scale in Partial Fiscal Decentralized Governments, the Case of Chile. And this is a paper that I'm working with Dusan Paredes, who presented like 2 weeks ago also in this same seminar. So to begin with, this is the agenda that I'm going to be following in this presentation, and we're going to begin with a brief introduction. When analyzing public spending, or when we want to compare public spending or the provision of public good between municipalities, we usually use 2 common measures. We can use either aggregate spending or per capita spending. Whichever measure we use will give different outcomes, because those cities that holds the greatest aggregate are necessarily the same cities that holds the greatest per capita spending. This means that the measure will give different outcomes depending on the measure we'll use, and this difference can have also many public or social implications. Just to see an example of this and to analyze the case of Chile that interests us today, we have here a graph that presents the aggregate expenditure in consumption goods and services for 2018. We can see that there are some municipalities such as Las Condes, Viña del Mar, and Maipú that have an expense of over 44,000 million Chilean pesos per year, which is very high. But the story completely changed when we see the cities that holds the greatest per capita expenditure. We now have cities like Ollagüe, Camarones, and Timauquel. This means that there is something happening between using one measure or another one. We believe that economies of scale is playing an important role here, that some cities are reaching economies of scale, but some others are not. And this is actually what motivates us to study economies of scale in local public spending here in Chile. To exemplify a little bit more, I have a photo of, in the left, a photo of Las Condes, which is the city that holds the top in aggregate spending. And at the right, I have Ollagüe, which is the city that holds the top in the per capita spending. At first sight, we can see that there are huge differences between these 2 cities, not only in their infrastructure, but we can imply that there's something happening also in the provision of public goods between these 2 cities. So before addressing this specific issue, I want to talk about 3 main implications or 3 issues that we have to take into consideration when talking about public spending and economies of scale, especially in Chile. So we will address each of these implications right now very, very briefly. The first one is that we can be perpetuating inequality among municipalities. Let us assume that the central government used the per capita measure as the sole indicator for public budget allocation decisions. Under this criteria, less budget will be directed to poor or lagged municipalities. To evidence this, I have created this graph in which we have between the development index and the per capita spending. And we can see that there is an inverse relationship between these two variables. That means that the municipalities that holds the lowest development index also have the highest per capita spending, which we see here Oyagüe, Camarones, Timauquel. And this pattern is repeated when we look for other variables such as education. This means that under this criteria, less developed cities will be receiving less or maybe none money at all, and we will therefore be perpetuating inequality. The second aspect to take into consideration is that Chile has an uneven and static distribution of population. As an example, Santiago, that is a functional region that has 48 municipalities and covers only 1.6 of the Chilean surface, concentrates around 43%, almost half of the country's urban population. And in Chile, this population distribution is also influenced by the extreme geographical environments of Chile. We have one of the most arid deserts in the north, which is Atacama, but we also have the Antarctica in the south. And this causes over-urbanization in some cities and less population density in others. This implies that some municipalities will be able to achieve economies of scale and others will never do it, maybe. And this will also affect the provision of public goods these cities would have. To evidence this, we created a ranking of these cities according to their population size, where the first place is occupied by the city that has the most population, the highest population. There are two interesting facts that we can observe in this graph. First, we can interpret this graph something similar to a Lorenz curve, when under total equality, we will have a line around here, just around here, where a change in the ranking will mean a proportional change in the level of population. However, we can observe that the lines are quite below equality. This means that there is a great concentration of population. In fact, if we look around here, about 90 cities hold most of the population in Chile. And the second interesting fact is that this uneven distribution hasn't changed much a long time. We can see both lines, which represent 2009 and 2018, and they haven't changed much over these 10 years. Finally, the third implication or issue to take into account is that we have to consider that Chile has or owns a fiscal decentralized model, where municipalities receive funds from the central government, but they can also generate their own local funds. In Chile, these funds are called ingresos propios permanentes. These funds are usually collected from three main sources: territorial tax, commercial property tax, and licenses and vehicle registration fees. However, one of the big problems is that the capacity to generate these local funds varies extremely between municipalities, and this causes some municipalities to be more dependent to their central governments than others. To exemplify this, we have created a Gini index, where let us remember that the higher the index, the higher the inequality. We can observe that in fact there is a great inequality in the collection of funds, whichever the source we use or we analyze. This means that this inequality can affect the spending level of the municipalities and also the achievement of economies of scale. So taking all this context into consideration, the objective of the paper I'm presenting today is to evaluate the presence of economies of scale in local public spending in Chile, emphasizing on its well-known particular geographical features, as well as the high fiscal heterogeneity that we just talked right now. Regarding the theoretical model we are using, I have chosen some of the main equations just to understand the model. If you want a little bit more detail or the step-by-step, please let me know, and at the end of the presentation, I can share with you the mathematical appendix. So right now we are assuming a common production function, Cobb-Douglas production function with constant returns, and we are allowing for municipal spatial dependence in technology. That means that the outcome It's a function of technology, capital, and labor. But the interesting part of this equation is that the level of technology of one municipality also depends on the level of technology of its neighbors. And this is represented by psi that we have right here. Then after solving this minimization cost problem, we will arrive to our cost function, which is equation 3. Until now, we have represented a common production function. However, we have to remember that we're talking about public goods. And a main characteristic that we have to address is the quality of these public goods. Therefore, the literature agrees that the quality will be determined by the level of output, by the level of population, and also by a set of exogenous factors, which will include demographic, social, and also geographical aspects and characteristics. And here we face a problem, and is that the quality of the good cannot be empirically addressed. The literature solves this by assuming that the level of output will be determined by the quantity demanded by the median voter. And this is expressed in equation 5, when we have also the price of the public good, we have also the disposable income, and some specific characteristics or preferences. And here we face another challenge, and is that the price of a public good cannot be empirically determined, because we don't actually pay a price for a public good, but we do it through taxes. Therefore, price will be determined by the tax price, which is represented in equation 6. After plugging all this together, we will finally arrive to equation 7, which represents the quantity demanded by the median voter. And finally, after some solving, plugging, and many other transformations, we will arrive to our expenditure function. Here we have that government spending depends on the spatially lag dependent variable, and also on spatially lag explanatory variables such as population, square population, which are our main variables of interest, and these are the variables that will allow us to address the presence of economies of scale. And we also have a vector that represents cost factors and demand factors that affect government spending. So until now, this is the structural model that the theory gives us. Remember at the beginning of the presentation that I told you that I'm going to present very, very preliminary results. So for the moment, we are not allowing the spatial dependence across municipalities. That means that in our production function right now, psi will be equal to 0. We did this because we wanted to have a comparative base and run a non-spatial specification first to be able to compare what happens when we include this spatial dependence. Right now, we are in the phase of exploring our data, and that's why we wanted to do it this way. So right now, my empirical specification is given by equation 9, where I have government spending. We also have a vector of municipal fixed effects, a vector of time period effects. We have our main variables, which are population and square population. Then I have a vector of cost factors that affect government spending, and a vector of demand factors that also affect government spending. And of course, the corresponding disturbance term. Regarding our data, we're using an unbalanced panel data for 10 years, covering from 2009 to 2018, and a total of 343 municipalities. In table 1, I present the summary statistics for my main variables. I will only address the main ones due to time for this presentation. The first one, of course, is our dependent variable, which I'm using the per capita consumption goods and services expenses. Then, of course, population, which is our main variables of interest. And also, I want to talk a little bit about the market potential variable. This variable we created using the size of the municipality and the distance between a municipality and its neighbors. A municipality is considered a neighbor if it's located within 200 kilometers of radius. And also we're using other cost factors and demand factors according to the literature. Regarding the results, in honor of time, I'm not going to present a table. I'm going to focus on the evidence for economies of scale and the optimum population level. Also, I will be presenting two versions of the model, one using fixed effects and the other one using random effects. I am using both type of effects just to explore the behavior of the data right now. So the first thing that we can see is that whichever type of effects we use, fixed or random, we can find that there is a U-shaped relationship between population size and the cost of providing public services. You can observe that as population grows, the cost is diminishing until we reach a point in which the costs begin to increase. The red line represents the optimum population level. To find the specific point of this population level, we have to take the derivative of our expenditure function regarding the population and set it equal to 0. And this will give us our optimum population level. And we also want to find the confidence interval of this population level, because we want to know how many municipalities are actually reaching economies of scale, how many municipalities are actually falling between this interval. So we found that the optimum population level varies if we use random effects or fixed effects, but in average, municipalities reach economies of scale around 100,000 population. This is very, very high. In fact, only 2 municipalities have population that fall between this interval. This gives us a little bit of insight that maybe an aggregated focus may not be appropriate for the geographical and fiscal reality of Chile. So therefore, what we decided to do is that our market potential variable that until now was used only as a regressor will now be used as an interaction. And this will allow us to take into account the difference or the different levels of population by levels of market potential. We divided this variable by quartiles and had the following results. We can now see that the story changed. Now, quartile 1, 2, and 3 reach the economies of scale at a very low level. That is approximately around 40,000 people. Very far from the quartile 4. Economies of scale are reached around 700,000 people. And in this case, the story also changes regarding how many municipalities are achieving economies of scale. For quartile 1, all municipalities reach this interval. Quartile 2, around 30 municipalities, depending on the type of effect that we use. And quartile 3 and 4, around 2 municipalities. To conclude with, this is still a work in progress, so we have many issues still to solve. But the first one, of course, is to solve our spatial specification. Also, we want to think of alternative measures of how to account for this fiscal responsibility that we talk in our introduction. And also, even though the results are interesting by themselves, we want to link it to something that can give us a little bit more of insights. Maybe see if the municipalities that reach economies of scale are the ones that have a better supply of public goods or not. And this is my presentation, and thank you very much for the opportunity.
All right, Alicia, thank you so much. Very interesting work. So I have a comment for you, actually 2 comments. So the number one is more on the method per se. It seems to me you're interested in finding breaking points at the end of the day, right? Are you dealing with 2 groups, 4 groups, you have those quartiles and so on and so forth. I'm going to send you some work by some French researcher called Jean-Pierre and Dorec. They actually started with the idea that we don't know how many groups we have in a large sample, and we don't know who belongs to each group. So they have a very interesting statistical approach in order to detect those breaking points. And that's something that eventually you may want to investigate. Number 2, you may want to make it a little bit clearer what your dependent variable really is. I have to admit, I got a bit confused, and from your talk, it seems you have 3 definitions. When you speak about the theoretical model, you indicate that your dependent variable is going to be the per capita public spending. However, when you show your table with the summary statistics, it turned out that the dependent variable is per capita consumption of goods and services. And then later on, you speak of a third one, which is the cost of providing public spending. So I'm quite confused as to what your dependent variable really is and how you really link the theory with the actual choice of the variable that is used in your econometrics. Could you clarify that for me, please?
Of course. Thank you, Sandy, for your comments. And yes, please share with me the paper that you talk about your French friend. Regarding the quartiles, that's one of the things I wanted to improve, because right now it's like very, very self-made, that I wanted to do about quartiles. But if there's another way of finding these breaking points, it would be even better. Regarding the second point of the dependent variable, yes, the variable indeed is per capita public spending, but the category of public spending that we are using is the consumption goods and services. We went to all the categories of the public spending and choose this one because it's the one that is more representative. It represents almost 70% of the municipal spending in our municipalities in Chile. So that's the measure that we're actually using.
Okay.
We
so
also intend to try with different measures, but right now this is the one that we are using.
So if I understand well, it's actually the spending by the government, so summing up local and federal, right? All of that amount that is going specifically to buy goods and services. Is that what
Exactly.
it is? Okay,
Yes.
now I understand better. Okay, sorry,
Yes.
Alicia, I got quite confused on that. Very good. Thank you for the clarification. Why don't we collect a few more comments and questions for Alicia, please? Okay, so if you have comments later on for Alicia, make sure that you contact her. We have your email information, Alicia. So thank you so much for your presentation. It's wonderful, and I really see from your talk how it is embedded into the work that Dusan presented 2 weeks ago. Thank you so much.
Yes.
Muchísimas gracias. André, muito obrigado to you. Thank you so much also for the presentation. And I really hope to see all of you next week in the same place and at the same time. Thank you very much. Have a good week, everyone.